All right, the last page of the purple 4.3 sheet was probably the hardest, so I'll try to go through these. I think I did 25 in class, but we talked about, okay, if you have the sine of theta is 0.3, so that's the y value, if the radius, you're in the unit circle. So if that's theta, then it says to evaluate, what's the sine of theta? Well, that's 0.3, they told me that. If I take theta plus 2 pi, well, here's theta, I add 2 pi, I'm right back where I started from, so that sine has to be 0.3. If I take theta and add 4 pi, well, 4 pi would be twice around plus your theta, ends up with the same spot. So if I take 0.3 plus 0.3 plus 0.3, I get 0.9. All right, similar to that is the second one. Cosine is 0.2. Okay, so that means the x value is 0.2. So when it says the cosine of theta, 0.2, if I take theta and add 2 pi, I'm right back where I started, so that cosine would be 0.2. And if I do 4 pi, that's twice around plus theta, again is at 0.2. So both of those, we're just kind of going all the way around the circle. All right, when you get to tangent, tangent of theta is 3. So tangent really means that my ratio of y to x is 3. So a couple ways I could do that. If I probably in this one wouldn't be on the unit circle. I would say, all right, let's call that 3 over 1. And so my y value would be 3, my x value would be 1. Okay, and I could figure out the radius if I wanted to, but I don't feel like I have to because I'm just dealing with tangents. So tangents are in a ratio of 3 to 1. So I have this theta in the first quadrant that's positive, and I have a y value of 3, x value of 1. So the tangent of theta is 3. Now the second thing they said is, what if I have theta and if I add pi? Well, pi puts me down here. And what do I know about this triangle? Well, this triangle would have a negative 3 for y and a negative 1 for x. But when I take the tangent, I would still get 3. So with tangent, if I add pi, it's going to start to repeat, and I have that same triangle because I have a negative over a negative. That doesn't work with sine and cosine. Sine and cosine, you have to go all the way around the circle for that to happen. And then again, theta plus 2 pi would get me right back to where I started, and that would also be 3. So the tangent of theta plus pi plus tangent of theta plus 2 pi would be 9. All right, same thing with cotangent. Let's try that. This tells me the cotangent is negative. So when I draw that, I either have to draw it over here or down here. I'll draw it in the fourth quadrant. That's x over y. So I'm going to let x be 2 and y be negative 1. Now if you're over here, you would have x be negative 2 and y be positive 1. Same thing. So there's your theta. So the cotangent of theta is negative 2. If I take theta and subtract pi, so here's theta. Subtracting pi means I'm going to go in this direction, pi units, puts me here, but again, that tells me that the x is negative 2, y is positive 1, so the cotangent is negative 2. And then if I take theta and subtract 2 pi, go all the way around the circle in the negative direction, I end up where I started with, negative 2, so I get an answer of negative 6. So make sure you think about, drawing the triangles and making sure that your reasoning makes sense when you do that. Okay, then you get to this one. This one has this dot, dot, dot means everything in between. So I have the sine of 1, sine of 2, sine of 3. So you've got all these angles all the way around the unit circle. You're trying to figure out the sine of, and as you go all the way around the circle, there should be some things that kind of line up. So let's just think about 1 degree. 1 degree, let's say, is right there. I know I made it bigger than 1, but there's 1 degree. It would line up with 359 degrees. They would have the same triangle, same reference angle of 1 degree. But this would have a positive sine value. That would have the same negative sine value. So they're going to cancel out. Same thing with 2 degrees and 358. They have the same reference angle. This sine is positive, that sine is negative. 3 would go with 357. 4 would go with 356. So all the way around the circle, everything's going to cancel out except for this one angle at 180 degrees. Everything else will be paired up and will cancel out except for 180. So really, after all these cancel out, the one that doesn't cancel out, that doesn't have a pair, is the sine of 180. And the sine of 180 is 0, so we don't have to worry about it. So when I add up all of those things, these all cancel out to give me 0, And then I'm left with the sine of 80, which is also 0. All right, let's try that for the cosine. So the cosine, I'm going to decide what cancels out. So when I start thinking of, let's say, 1 degree, now 359 is not going to cancel out with that. I could say 179 would, because this would have a positive cosine with a reference angle of 1. That would have a negative cosine with a reference angle of 1. So 1 and 179, 2 and 178. So all of those in here would cancel out, again, until I got to 90. 90 really wouldn't have anything to pair up with. So in all of these, I would have to pair up with there, I would have everything but 90 to pair up with something. So then I'll go down to this quadrant and say, okay, if I had, and I haven't done 180 yet either, I guess I have to keep 180. That hasn't been paired with anything yet. This hasn't been paired with anything yet because all of these cancel with these, leaving me with that one. Do the same thing down this quadrant. 181 goes with 359. Reference angle of 1, but the cosines are opposite, so they go away. So I know everything from 181 all the way down except for 270 are going to cancel out. So everything over here will cancel with everything here except for that one won't have a match. So really everything that paired up that had opposite x values was everything paired up except for cosine of 90, cosine of 180, and cosine of 270. So if I add those up, cosine of 90 is 0, cosine of 270 is 0, and cosine of 180, negative 1. So all of those added together would give me negative 1. So think about the pairings. So if you need to sit and even draw more examples of which things pair together so that they cancel out. Okay, and then 3132. This tells me that I have f of theta equals the sine of theta. That's my function. And so it's telling me f of a is 1/3. So f of my angle is 1/3. Which really tells me, again, f of a is really equal to the sine of theta. So it's telling me that the sine of a equals 1/3. That's what that's saying. Okay? So if f of theta is sine, and f of a is 1/3, this is my y value when x is a. So sine of a is equal to 1/3. So what does that mean? That means the y value is 1, the r value is 3. It's y over r. So then it's asking me, what's f of negative a? So if this is a, what would be f of negative a? If I took a, if this is positive a, negative a is down here, right? Because negative, in the negative direction, I'm going a radians or degrees, whatever it happens to be. So if negative a is down here, then I know that the y value is negative 1, the r value is still 3. So when it says what's the f of negative a, it really means what's the sine of negative a? Well, the sine of negative a would be negative 1/3. So think about any angle you have here, when you take the sine of the opposite, that sign is going to change sign because it's going from a positive to a negative. This one says, what's f of a? Well, that's 1/3. F of a plus pi. So if this is a, I'll draw the picture back, maybe over here. So if this is a, and that was 1/3. A plus pi, well, if I take pi and add pi to it, now again I have a negative 1 and a 3. So that would be a sine of negative 1/3. And if I look at a plus 2 pi, if this is a, 2 pi is all the way around, I'm back to where I started, that would be 1/3. So really, these two cancel out, so I'm just left with 1/3. All right, we'll do the same thing with cosine. So cosine of an angle, so if I draw my theta, when the cosine is 1/4, looks like that. When I look at negative theta, that's down here, negative theta, or negative a, x still is 1, and y is, or r is 4. It's only the y value that's changing when I look at negative a. So the cosine of negative a, so if I go in the negative direction, is still going to be 1/4. And then over here, if I take f of a, I get 1/4. F of a plus 2 pi, so if I take f of a, which is here, add 2 pi, I'm back to where I started. If I take f of a and subtract 2 pi, I'm still back where I started, and so I get 3/4. So the one thing you'll notice about this, here it said, f of a is equal to the opposite of f of negative a. This ends up being an odd function. That's why that works that way. This one, when you take f of negative a, you get what you started with. It equals f of a. Cosine ends up being an even function. So that's something we'll talk about later.